Okay guys, welcome to today's video where we're going to be repairing this Metcal soldering station. It is a MX 500P and it's got kind of the common problem with it. I'm pretty confident it is the switch that's the problem, but it could be something else internally on here. So we'll take a look at it, but basically what's going on is you plug it in, turn it on, and the power light just starts to flicker. It doesn't really come on, and it definitely doesn't heat up the soldering iron. So let's get this thing apart, take a look at the inside, and see what we find. Okay, so let's get this thing taken apart. First thing we're going to do is take this little cover off here, which kind of pulls off this way, and then comes up. So just the little tabs are right there. Switch comes up, and then it reveals it's just kind of a regular switch right there. And then ½ inch will work with these. They might be metric, but ½ inch fits. They're not super tight. Okay, now the screws are in the back here, so we have to take these off and just loosen that one up. Okay, now that we have the cover off, we have this screw right here to remove, and this one. This holds down the sleep timer button, and then these screws go all the way through the transformer, you'll see in just a moment. Okay, and then the last thing holding it down is the mains input here. They just kind of slide on there, so, and it's free. Now, the switch will just slide right out like that. You can take the switch out with it. So while the switch is probably our main problem, you'll also see this cap is swollen, so we're going to go ahead and replace that. This cap is on the mains input. Okay, so your mains power comes in, goes through this transformer, and you get roughly 19 volts out, and it comes over, and you have your rectifying diodes, which is this guy right here, that rectifies it into DC, and this is just the filter cap for it. So yes, this could be loading it down enough to make it not work, but also the contacts in this switch is a super problem, a common problem, and this is definitely a high mileage switch here. So let's go ahead and get this cap out and replace it. Unfortunately, I don't have a new one to put in there, but I have a used one that came out of another Metcal unit here. If this does fix it, I'll put a new one in the other one as well. That unit is broken, so I have two of these to fix, and I just figured I'd borrow this part for now to get this one up and running, and then just order a new one to fix the other one. Okay, so for the orientation of this cap, we have a square pad here, which is actually the positive, and a round pad here, which is the negative. Normally you reverse that. Normally the square is the negative. At least when I design circuit boards, that's what I do, is pin 1 will either be square or the ground will be square, depending on what I'm doing. So, yep, we got this heated up, so we're going to be using our Hacko equipment to fix our Metcal here, the irony. So we can definitely see that it is swollen, so the ESR is probably affected here. Let's just see what we get. So to give you an idea of the condition of this cap here, I got it on the LCR meter, so we're at 500 milliohms for our ESR, and then we can go capacitance, and we are at 2.04K, so not the best condition, but it could be worse. So I really don't think that this completely is our problem. It definitely could have been a worse cap. Let's put just a different one. It's slightly, so here is a brand new 2.2K. It is a 25 volt instead of a 50 volt, which is why I didn't put it in there. So, you know, got better ESR on it and better capacitance in there. So this is half the ESR of the other one. So yeah, it wasn't a happy cap, but it also wasn't a dead shorted bad cap. So I don't think that's entirely our problem. It's probably also the switch, which is a super common problem on these particular units. So let's go ahead and put our good replacement cap in there. So the negative was the round side. So we don't actually have a mark on the silk screen here to let us know. So we just got to pay attention to those pads. Okay, so let's try to do something about the switch here. It's most likely our problem, and I really just don't feel like ordering a replacement right now until I get the unit working. Then maybe I'll replace it, but it is just a switch. So definitely there was a lot of corrosion here on the connector itself. So let's try cleaning that up. Maybe we just had a bad connection there. But it's most likely the contacts inside the switch itself. So we're going to take this syringe here and try to get a little bit of deoxide into it. I don't have a lot of success taking apart switches and then getting them back together working. So I'm just going to try to feed it down in there and just flip the switch a bunch of times and kind of hope that gets it working. Just every little crack and crevice on here, get a little deoxide in it. And then we'll just, I can definitely see it coming back out the bottom end here, so I think we got plenty of deoxide down inside of this thing. All right, I think I'll call that good. Let's get it back on here and then get this thing put back together. Let's put a little fresh thermal paste down in there just to make sure. And of course, whenever you work with thermal paste, it is going to get on your hands. Okay, so let's plug this thing in and test it out. Okay, so we have a green light, no air light. We have it switched in the right position. So this is likely working. Let's see. Yep, there we go. We now have a working soldering station. So pretty simple repair there. It was most likely the switch that actually fixed this, not that cap. But that cap was definitely going to be a problem in the future, so we might as well have taken care of it now. It could have been the problem, but I doubt it. I'm confident it was the switch. So yeah, I mean, I'm glad we got this thing out of there before it started leaking all over the board. This definitely would have caused significantly more problems in the future, so probably a good thing the contacts got dirty on that switch. And if one of these works, both of them work, because all's what there is just the switch in between them. So you have to turn it off if you don't have one connected there. So let's go ahead and do that, because it'll just go into an error state, and these things don't self-reset from an error state. See, we went into an error state, switched the switch up, and it didn't turn green. That's just because these things don't self-reset. There we go, we're green now. Let me put a second one on here so we can actually switch in between the two. My only second handle I have is the hot tweezers, so let's go ahead and get that on there. Okay. See, now we can switch between the two because there's actually two units there. These actually take a little while to heat up compared to other Metcal things, so let's give those a second to heat up. There we go. They are ready now. So now let's finish putting this thing together now that we've verified that it does in fact work. And the little green thing fell off. Where'd it go? Oh no, the green thing's just like taped on there. So this green reflects to let you know which one you're on in between the hole here. All right, let's finish putting this thing back together. Okay, so let's just take a quick look at the schematic to this thing since it is available on the internet. So if you just Google this, you'll find the schematic if you need it for working on one of these. But let's just talk about what we did do. So we replaced this capacitor right here, C6, which is this bulk capacitor on the end of the full bridge rectifier here. So it just kind of, you know, smooths out that sine wave out of that rectified AC voltage there. So we're rectifying the 19 volts out of this transformer. And then we go into two different voltage regulators. We have this buck boost regulator right here. I mean, it's just a switching regulator. I haven't looked too close at this, not sure which one it is. So yeah, we have a switching regulator here, and then we also have another regulator right here that makes the 18 volts that everything kind of runs off of. And this is where we switch off the power to the input of this IC right here. So that's really what we fixed here, was cleaning out the contacts of the switch so that way it'd make good contact. We know this wasn't shorted out or anything, not only from testing it and looking at it outside the circuit. We knew before we even took it out of circuit it wasn't shorted because we hadn't blown this fuse, we hadn't damaged our transformer or our rectifier right here. So there was really no way for that to have been shorted and like completely pulling it down. But with it being kind of like a higher ESR and a little bit out of value, we were probably noisy. So I don't think that was enough to shut it down. I think just bad contacts on the switch, we weren't getting enough current out, or we just weren't getting power at all to our switch regulator here. Or well, I think this one's linear. I haven't looked too much into it either. 78, 18, yeah, those are linear. So that's a linear regulator there. But yeah, this schematic's super helpful for if you need to like really get into this and repair it. One of the other interesting things I just wanted to show in here is, you know, this isn't like it's a dual supply thing. Like it can't run both of these at the same time, which I already kind of showed that. But yeah, you just switch in between the two of them. So you could take a single one with just a single thing and make an adapter to switch in between them, and there you go, it would work. So I think it's kind of like a hokey thing that this is a dual port when it's really, it's just a single port with a switch that lets you switch between the two. But the other thing is that internal little button switch there, that's you got that JP2. It goes to this set screw right here, so you can turn on or off that auto sleep function that these have. And yeah, that's really kind of all I had to go over with it. But yeah, you have the whole BOM here, so you know exactly what everything is on here. And then you have your layouts, that way you know exactly where everything goes if the silk screen doesn't say. And yeah, that's really it. So the schematics out there. So if you ever have to work on one of these, I do recommend downloading a schematic so you can look at it and really kind of figure out what's going on. That's really all I have to say about the schematic. Okay, well, I hope you guys enjoyed watching me repair this unit and getting it working again. So I'll be keeping this one for myself. However, be sure to subscribe to the channel so that way you can catch the video of doing the giveaway on this. I am eventually going to do a giveaway on this one, mostly because of the cosmetic damage to it. The housing is cracked right there, so it's not really worth too much for me to sell it on eBay or anything, but it works perfectly fine. There's nothing wrong with it. The main thing that's holding up doing the giveaway is I am going to try to find a handle for it, so that way I can give you at least a handle, maybe a stand as well with it, so that way you have a fully functioning thing. But worst case scenario, it'll just be the power supply and you'll have to get the rest of it. But that will be another video, and there'll be a link in it. Do it the same way as all my other giveaways, where all you have to do is pay the shipping. I'm going to put it in a medium flat rate box, which I think is like $18 for shipping. They are pretty heavy, so it wouldn't be too much cheaper to put in anything else. But yeah, I hope you guys liked the video, and I will see you in the next one.